Hi, Dave Malafont, Chairman of the America's Supply and Logistics Summit. And with me is Michael Galluzzi from NASA, and I'll let him introduce himself.
Thank you, Dave, very much.
Yeah.
This is my first year presenting at the summit. My name is Michael Galluzzi. As Dave mentioned, I work for NASA. I work in what's known as the Swamp Works Lab, engineering director at Kennedy Space Center, working on surface systems. So working in situ resource utilization, robotic technologies, to very advanced manufacturing disciplines, such as like regolith-based additive manufacturing, 3D printing, which has a strong relevance to how we support things in very distant planetary bodies, and how it has a very strong influence on interplanetary supply chain. Mm-hmm. So this is one reason why we actually presenting today with some of these technologies, the NASA spin-off technologies, in terms of understanding how do you support something at such a remote distance that's literally millions of miles away. Talk about true end-to-end. This is the extreme end, and looking at some technologies that are also commercially viable and available in terms of NASA spin-off technology.
So what are some of those technologies that would be beneficial for supply chain?
Sure, I'll give you an example. So we, during space shuttle program transition, we actually created an economic resilience model, meaning so when we terminated shuttle, there was a significant time gap between programs, the human spaceflight program. At that time it was Constellation, and we weren't really quite sure as to how that impacted, that time delay, how that would impact our critical suppliers, not just our sole source suppliers, but down into the multiple tier level. So we would have what had a bullwhip effect, if you will, did that delay cause down into lower tiers. And the truth of the matter is we just didn't have very strong understanding, any visibility down in that level. So we had created tools. We did scour the world, literally, for applications that fit our need. Didn't necessarily find anything. Something came close, but we ended up developing what I call a demand or an economic demand aggregator, or a resilience model that assesses multifunctional relationships between, say, program transition activities, and what does that cause to the supplier liquidity, to the supply chain liquidity, to the program overall health.
So this goes all the way back to how far down in the supplier tiers would you go? So
absolutely, we try to go. Excuse me. We try to go as low as possible. Primarily, we have issues. Well, the government, many other private enterprises do, with counterfeit parts. Mm-hmm. And I don't mean the Gucci bags. In our case, obviously, we'd be more concerned with things like microelectronics or IEEE parts. We would be concerned about what we call Trojan horses entering into the chain. So the lower we go into the tier structure, which they typically do enter, maybe 6th, 5th, maybe 7th tier, the better off we're going to be to understand what those risks are and mitigate them as quickly as possible, and also have a very clear understanding of not just what, let's say, particular program we may be looking at, but what other government agencies, and even to some degree what other commercial part.
So if we take what you've developed, how do you feel other companies, other industries can apply it?
Oh, very strongly applied.
Yeah.
So as an example, if you were going to do a redesign or obsolete, if you were plan out a termination of a certain product line, okay, so that supply chain that supports that particular product line may also support another design. Okay, so you're going to cut the lifeblood a little bit from that supplier. Will that have an impact on the other product line? Will you be looking at quality issues in that product line? Because we know there's a distinct correlation between the supplier liquidity and the product quality that's delivered in product. So the better understanding you have on the resilience side, the better you're going to be in terms of quality and on-time delivery and overall customer satisfaction.
Which is very critical for NASA to have all of those in part of your supply chain.
Absolutely, yeah. Absolutely. The other thing, of course, we're concerned with, not to change subject too much, is as technology advances occur in manufacturing, such as with 3D printing, additive manufacturing. I mentioned we do advanced manufacturing disciplines. We're looking at regolith-based additive manufacturing, if you will, making components out of moon dirt, let's say. So the issue in the supply chain here terrestrial is that if you have this technology as it's better adapted, it becomes more technically feasible, economically feasible, applied in commercial sector, then you have to understand what kind of an impact will that have on your supply chain. And meaning that if you have a critical sole source supplier that does not adapt to the technology, will they die? When the competitors are actually better fulfilling their demands, or for that matter, maybe the customers even manufacturing themselves, they've got the technology. I mean, these are all things that need to be addressed.
This is Michael from NASA. Thank you.
Thank you very much, Dave. I appreciate it.